Thank you very much for the kind introduction. So we are going to start our session. In today's session, first of I'm going to discuss what is the difference between artificial intelligence, machine learning, and also the deep learning. Am I audible? Am I
Yes,
audible?
sir. Yes, sir.
Thank you. Right. In second part, I'm going to discuss about the different applications, practical life applications of machine learning and let's say deep learning. Finally, in last part of my presentation, I'm going to discuss about the if you create one deep learning model or machine learning model, how to judge the accuracy of the proposed model. That is really important actually, right? So you must be really aware about the different terminologies they are using, right? First one is, let me share my. So these days we are listening these three words all the time, right? AI, machine learning, and the deep learning. So first we need to understand what is the connection between these three things and what are the different aspects of these three terminologies, right? So let's say AI is like artificial intelligence. It is a really bigger set, right? Machine learning is the subset of the AI. So let's say this is AI, this is machine learning, and the deep learning is you can say the subset of the machine learning. So this is deep learning, right? So let's say a lot of algorithms are available. Let's say A star, heuristic search, DST, DFT. So many algorithms are available. They are the part of the artificial intelligence. Machine learning means it's pretty simple. Machine learning means you have some kind of features. Based upon the features, you want to make the prediction of the something, right? For example, I'm currently living in Jammu. So I want to predict the houses of the Jammu, house price of the Jammu, right? So what is going to be the input feature? In this example, the input features are going to be how far is the airport, how far is the ATM, how far is the school, how far is the medical hospital, right? So let's say these four are going to be the inputs. Right? So, medical hospital, ATM, airport, let's say grocery store, let's say, right? So based upon these four inputs, there can be multiple inputs also. Based upon the four inputs, I want to predict the price of any house. The size of the house is also going to be a feature. So based upon these five features, I want to predict the price of a house, right? So these five are going to be the input features, right? So based upon these input features, we can use any algorithm. For example, we can use the linear regression to predict the housing price, right? So the relationship between them is going to be. So relationship is going to be housing price equal to summation of I equal to 1 to 5 alpha and feature I. These features are already known for, let's say, my training data set. I have prices for 1,000 houses, right? This FI I already know for the housing prices, but these alpha I's are unknown. So take any machine learning or the deep learning algorithm. Job of those algorithms is to find out these alphas, find out these unknown parameters, right? Because the size of the house is much more important than the how far is the, let's say, grocery store. That means the alpha corresponding to the um, size of the house is much more important, right? So job of any of the machine learning or the deep learning is to find out these alphas. Okay. So this is the basic idea about the machine learning, right? But let's say I want to create a machine learning model which is going to do the facial recognition, right? So facial recognition means in machine learning, I first need to find out the important features. What are the important features, right? So if you want to identify the face of a person, the feature. What is the distance between two eyes? What is the distance between your lips and the nose? This, what is your skin tone? If you have some kind of wrinkles on your face, these kind of things can be the features. So in machine learning, identifying the important features are the two important things, right? So in machine learning, first thing which we need to do is identify the features, right? In the housing prediction of housing price, I give you an example where the input features was, let's say in my example, it was how far is the ATM, how far was the medical hospital, how far is the, let's say, school, airport, and also the area of the site. So these were the input features, right? So machine learning means you need to have the information about the different kind of features, okay? But identifying these features all the time is a really difficult task. We cannot identify the features all the time, and who knows the features which we are identifying are correct ones, right? For example, in predicting the housing price, if I find give one feature, how far is my house from the chief minister's house, for example, I'm giving some random example, but that feature is not really useful, right, for predicting the house price. So I just want to say that the identifying the correct features is a really difficult job, right? So this problem can be solved using the deep learning. Okay. In deep learning, no need to identify the features. Your deep learning model is automatically going to find out those features. Okay. So that is the basic difference between the machine learning and the deep learning. Machine learning, first we need to extract the features, then train the model. In deep learning, no need to extract any kind of features. Your deep learning model is automatically going to identify the important features. This is the basic difference between the machine learning and the deep learning. So of course, other difference you can say, in machine learning, you don't need to extract features. That means amount of data which you require to train a machine learning model is less as compared to deep learning. I'm just trying to give you one thumb rule in general. If you want to train a machine learning model, the number of images which requires are at least 1000. Below 1000, if you are training your model, machine learning model, it's not going to be accurate at all, right? Same thumb rule. If you are trying to train one deep learning model, the number of images, I'm trying to give you an example using the images. Number of images should be at least 10,000. Okay. Afterwards, you can apply the data augmentation or some other technologies to increase the amount of data. But basically, you require 10,000 images at least to train a deep learning model. Okay. So I hope the basic difference between these three terms, AI, ML, and the DL, is really clear to you people, right? So next thing which comes into our mind is, I'm just trying to give you the overview. The next things which we comes into our mind is which programming language is preferred for the this machine learning or deep learning task, right? Most of the people in this world are using Python, right? So in Python, a lot of libraries are available which is really useful for machine learning. Is the let's say Keras. Another one is the TensorFlow. I hope you are able to read my. I hope. Right. Third one is Panda. Fourth one is the NumPy. These are the Python is the like programming language where some kind of libraries are already available in pandas in Python, which is Panda, NumPy, TensorFlow, and Keras. You can write down your machine learning code or deep learning code using the TensorFlow, but the TensorFlow writing code in TensorFlow is slightly more difficult. At least for the people who have just started to work in this area, it's really difficult for them to write down the code in TensorFlow. But there is a like one more library is available which has backend TensorFlow. Okay, TensorFlow or let's say Cafe, and 5-6 years ago, people used to use Cafe, but these days no. All of them are using TensorFlow. Okay. So in order to have Keras in your Python, TensorFlow should be there. TensorFlow is going to work as the backend. Okay. So let's say I want to write down a really simple deep learning model which will classify the different breeds of the dogs. For example, different breeds of the dogs. You can write down the your deep learning model in Keras in 10 lines, not more. So TensorFlow, it's difficult to write down the program, but if you use Keras, it's pretty easy. 10-20 lines of the code are going to be much more enough to write down a deep or machine learning program. Okay. Okay. So in using the machine learning and deep learning, generally, most of the times we are solving two different problems, right? One is classification. Another one is the regression. Right? Classification means you have one object, you want to classify that object into category one, either in category 1 or category 2. This is classification, right? You can see, take an example. I have like a basket of fruit. Banana is there, orange is there, mango is there. I want to train a model which will tell what kind of objects are available in my basket. Right? This is a classification problem. Output is going to be in terms of 0 or 1. In binary classification, in multi-class classification, the output is going to be in 0, 1, 2, 3, 4. That means output is going to tell you which category that particular object belongs to. Right? So another one is the regression. Regression means giving the output in real numbers. So for example, I gave you an example predicting the price of the houses. House can be 1 million, 1.1 million, 1.2 million, 1.25 million. That means the output it is going to be in real number. Correct? But in classification, output is not going to be a real number. So regression means continuous output. Right? Another example you can take is the like what is going to be the price of the stock tomorrow, for example. The stock market is of course going to be the real number, right? 38,000, 37.5 thousand, 40,000, 41,000 kind of thing, right? So output is going to be a real number. Mandeep, is it okay to you? Are you able to follow? Mandeep? Are you able
yes,
to?
Sir. Yes, sir. Yes, sir.
Great, thank you.
Yes, sir.
So that is regression problem. Another example you can say is there are like 500 people are spending their unit. You want to predict their height. Of course, height is going to be a real number, right? 5.8 inch, 160 centimeter, 165, 170 kind of thing, right? So you can always classify this classification problem into the regression problem into the classification, right? If you suddenly increase the number of classes, that means you are going towards the regression problem. In regression problem, if you do some kind of quantization, let's say a person, just an example, if a person is taller than 5.6 inch, he is tall. If it is lesser than 5.6, he is a short person, right? So you can always convert this regression problem into classification and also the classification problem into the regression problem. Okay. Right. So I'm sure in this next 5 days, you guys are going to have at least the basic knowledge about the machine learning and deep learning. But I'm sure you're not going to get how to implement things. Basic idea you will get, but implementing the difficult task is going to be really difficult. So I'm trying to give you one link, Andrew Angie, right, on Coursera, which is a free course, right? 5 courses are available. Okay. Right, 5 courses are available for entry NG course on Coursera, which are completely free right now in this Corona pandemic situation. So the young people should go and take this course and try to implement things actually, right? So my simple suggestion is try to grab this opportunity because this course is completely free right now. Okay, and it is going to take approximately 1.5 months to complete these 5 courses. So let's try to find out the different kind of applications of machine learning and deep learning, right? I'm sure you guys are able to see applications every day, but you might not be able to appreciate them, right? So let's discuss about the application. I want to give you one really good example, right? If you take the X-ray of a person affected with the COVID-19, right? There will be some kind of purple patches available in his X-ray images. Okay, and those purple patches are very close to the patches which appear in tuberculosis, TB, right? They are really close to each other. So some of the researchers have suggested that you can find out the corona using the X-ray images of the patient. Okay, so COVID-19 detection. One, I'm trying to give you some really like layman's example. COVID-19 detection. You can do it. And frankly, a lot of people tried to work in this area, but there was a failure. In later part of my discussion, I'm going to tell you why those algorithms failed. Okay. As Usha ma'am already told you about the self-driving cars, right? These are the like pretty simple examples. Third one is the NLP, natural language processing, which is used in Alexa. Right? Alexa is one of the example by Amazon, but there can be several other things by from Microsoft, Google also, and everywhere, right? So NLP, natural language processing. Fourth one you can say computer vision. Right? For use of the deep learning in computer vision is really huge right now. Right? Most of the people who are working in the area of computer vision, they use these deep learning technologies. Okay, so you can give a lot of examples of computer vision, right? That means if you are driving a car, if one object is coming in front of you or not, object detection you can do using the deep learning, right? Another example is because I used to live in Delhi NCR region, and in NCR region, a lot of fog is there, right? In because of the fog, a lot of accidents are happening in NCR region, especially in this Delhi Yamuna expressway highway, right? So you can create one algorithm which will do the dehazing, removing the haze in real time, right? That can be one example. Another example in the case of heavy rain. In the case of heavy rain, it's really difficult to drive. So you can have one screen where input is going to be the video with a lot of rain, and output is going to be the rain removed video. I mean, I want to say de-raining, right? In the case of de-raining, the video is not going to have any rain. Driver is not going to face any problem in driving the car, right? Same example is also applicable in the case of railways, right? Because in generally in winter time, where in December and January, whenever there is a lot of fog or haze, right? The trains are getting delayed. The reason is there is the amount of visibility is very poor, right? And the driver is not able to take risk to run the train at 80 or 90 kilometers per hour. This is the reason why the trains are getting delayed. The simple solution for this problem is what? Apply a model which will do the dehazing. Output is going to have an image without any haze, right? So applying simple model will help the Indian Railways a lot. Okay. The current problem available in this domain is the model which has been trained for the dehazing, they are not in real time. They are not in real time, right? That means they will take approximately 3 and 4 seconds to process an image. That means it is going to take 4 seconds to do the dehedging part, right? And you cannot wait for 4 seconds because any object can come in front of your car anytime, right? So like giving a delay of 4 seconds is not really good enough. So this is the issue which the people are facing right now. The dehedging algorithms are really good enough in computer vision, but most of them are not in real life, right? Real time scenario. So we need to decrease the inference time for these deep learning models to apply them in real time. Okay. So I gave you one example of the haze removal. Another example you might be seeing these days in your Google Map, right? In Google Map, what is going to happen? In sometimes the Google GPS is not working accurately, and the Google is not able to identify your location. Right. So what it is going to do? You need to take your phone and take your phone in all the like 360 degrees, and the Google will be able to identify your location, right? So all of these things are based upon the computer vision and deep learning, right? So here I'm trying to give you a few examples, but there are frankly millions of examples are available right now. Okay. And you guys must be using like chatbot these days. Let's say you are going to some website and your question answer session, right? Do you think any person is sitting there and answering your question? No way, because at the same time millions of people are asking questions, right? You cannot ask 10 people to sit there and answer your questions. No, all the chatbots are doing those things. Chatbots are based upon the natural language processing, NLP. So in deep learning, generally what's happening, right? So whenever you are playing with the images, if you are handling the images for some particular objective, you always need to use CNN, convolutional neural network. For images, CNN, okay, convolutional neural network, right? So there can be a million type of different convolutional neural networks, right? Right. First one is how many layers you want in. I will go into detail later, but how many layers you want in your neural network, right? Right. What kind of how many nodes you want in particular layer, right? So different kind of neural networks are available. Right? The most famous neural networks available right now in the literature are ResNet, ResNet 101, then it's TenseNet, then again it is going to be the VGG 16, right? VGG 19, VGG 16, VGG 19. Then there are, multiple options are there. Mobile name. These are the well-trained models available right now on open source. They are open source, right? They are really well-trained models, right? They are most of them are trained on the ImageNet dataset by Google. If I'm correct, I'm not 100% sure, but they have trained this model on 10 million images, 1 crore images. They have trained their model, right? Okay. So let's say if you are playing with the sound or speech, then you need to use RNN, which is for sound, speech, any temporal data, right? Any data which depends upon the previous data. That means there is a correlation in temporal domain, right? Sound has some temporal dependency, right? So there you need to use RNN, recurrent neural network, or LSTM. LSTM is the one of the part of the RNN, or you can use GRU, state recurrent unit. These LSTM and GRU are the part of the recurrent neural network. Okay. So RNN for sure, for sound and speech use RNN. It does not make sense to use these CNNs for the speech. And the vice versa, if you are playing with the images, don't apply RNN, because in images we do not have any dependency upon the previous image. unless you are using the video, right? So sound RNN, video or let's say images CNN, CNN, right? So now I'm going to teach you about the evolution matrix. Matrix for classification. Right? Because in due course of this 5 days, you are going to learn about the different classification models. Right? About let's say linear regression, which is a regression, logistic regression, softmax layers. So many things you are going to learn in next 5 days. But in this lecture, I'm going to teach you, let's say I created one deep learning model and someone else created deep learning model. How to judge which one is going to perform well and which model is the better one, right? Which is called as the evolution matrix, right? So I'm going to discuss in today's lecture, right? So the most famous one is the confusion matrix. Pretty simple and pretty easy. Let's say this is your actual level, right? And this is your predicted level. Right? This is true, this is false, this is true, this is false. That means actual level means I discussed earlier, right? For training any machine learning and deep learning model, you need to have the training data, right? The training data is the actual level. Here, machine learning and deep learning model is going to predict its level, right? That is also going to predict, right? To identify how accurate or like how poor your model is. Okay. So let's say the actual level was true and your model is able to predict it as true. That means true, positive. This means predicted level. Okay, positive means true. This second letter from right hand side is the predicted level. Okay, and this first one defines if the predicted level is true or false. Right, predicted level was positive and fortunately it was also positive. So it's true positive. Second one is going to be false positive. Here you can see the predicted level is positive, but unfortunately actually it was a negative, right? Because you can see actually it was false, so negative. That's why it's false positive. Guys, is it okay? Please feel free to ask any question if you have. Please feel free. Anybody has any question? Please feel free to ask questions. Okay.
No, sir.
Correct. Thank you.
We can have the questions towards the end of the session, sir.
Sure. Thank you. Right. Similarly, here you can say true negative. Predicted label is negative and it was originally a negative. So true negative. Next one is negative. False negative means prediction is negative, but this is a positive case, right? So I hope you are able to understand this confusion matrix. So whenever you are creating any machine learning or deep learning model for the purpose of classification, in order to justify that your model is good enough, you always need to give this confusion matrix. Okay? This confusion matrix is true. So you can appreciate one thing from this confusion matrix, that you always need to reduce this false positive and false negative. You always need to have this false positive and false negative values to be pretty small, as small as possible, right? If your true positive or true negative. That means you are classifying them correctly. Should be as high as possible. Okay. So this is all about confusion matrix. Okay. Okay. So let's try to create this confusion matrix one more time and try to understand about different parameters. Okay. So first term which I'm going to define is the PR. FPR means false positive rate. This is equal to FP divided by FP plus EN. That means false positive divided by the false positive plus true negative. That means this term. So what is this false positive rate is defined? Out of actually negative data, how much you are incorrectly classifying them. You can see from here. I hope you are able to see this all shape, right? Out of actually negative data, how many you are classifying incorrect. Okay, this is called as the false positive rate. Similarly, you can define one more term which is called as the false negative rate. That means Fn divided by Fn plus Tp. That means this term. That means out of total positive values, how many you are classifying incorrectly. This is the false negative rate. I will give you the practical applications of these things in later slides. Okay. So third term which I'm going to define is the accuracy. I hope you guys are able to understand this. Accuracy is pretty simple. Accuracy means how much you are classifying correctly out of the total amount of data, right? That means true positive plus true negative divided by the true positive plus true negative plus false negative plus false positive, right? If somebody says my model accuracy has 70%, that means out of 100 data, you are able to classify 70 data in a correct class. That is the mean of the right. So whenever you are training any model, you will see this accuracy all the time, right? But some of the drawbacks are associated with this accuracy term, right? It is always saying that 70% of the data has been classified, but it never says a few terms. Out of the 30% remaining data which you classified incorrectly, you never said 30% about the remaining data. That means accuracy does not give us any information if this is a true negative. No, I mean it is a false negative or false positive. That means a positive class has been classified into negative or the negative has been classified into positive, right? Correct. So you can see one example. False positive and false negative. Let's try to understand in somewhat detail. False positive means the predicted class was positive and it is incorrect. False negative means the predicted class is negative and it's incorrect. Let's take the scenario of the COVID-19. Right? Let's say some test is saying he is positive and which is incorrect. That means he is a negative person. What is going to happen? He might be in quarantine 14 days, but we are not risking anything with the life of a person. Right? False negative means doctor says, let's say some doctor is saying person is negative, is positive. That means it is a false negative case, which is quite dangerous scenario. Which is a quite dangerous scenario, right? It might cause the life of a person. It might cause the life of a person because doctor, or let's say I don't want to blame doctors or anyone. Let's say some particular test is saying the person is negative, but he is positive. That means the test results are incorrect. In this scenario, the false negative is too dangerous. In this scenario, false positive, we can handle it. It is not going to cause the life loss. So this accuracy, if somebody saying my accuracy is only 70%, some people will say, okay, your model is really poor. But no, remaining 30% of the data is also important, and we cannot find out that data is like useful for us or not, false positive, false negative. It cannot be given using the accuracy. Okay, this is the reason why accuracy is good in some sort of idea, but not all the time, right? So this accuracy is not good enough all the time, right? Let's take an example of RT-PCR, right? Sorry, take an example of a rapid antigen test. Okay, let's take an example, right? So 70% accurately it is saying it is positive or negative. False positive 25%, false negative 5%. Just think and tell me this model is good enough or not. The rapid antigen test in general gives 70% accuracy, but rapid antigen test is good enough or not? Just think, right? My answer is in this scenario good enough, because the false positive rate is 25%. That means for the negative, right? For the person who is test is saying positive, but in reality it is negative, that's acceptable, right? Not much to lose, right? Similarly, but false negative is too dangerous in this scenario. But false negative is only 5%. Okay. So this is the reason why this accuracy is a really poor indicator of the performance of any classification algorithm. Right? Reason is I pretty sure, right? It only gives you an idea about the true classification, right? But it does not give any idea about. It does not give any idea about the false classification, right? That's why this accuracy is not really good enough. But let's say if somebody says my model is 99% accurate, then we can still believe the accuracy, right? But if we say my model is only 70% accurate, then I cannot say this is a good classification model or a poor classification model. Okay. Let's take one more example to criticize this accuracy. Let's say someone created one model which will identify if a person is a COVID positive or negative, right? Okay, and his model is always saying, okay, person is not affected with corona. Okay, it is always saying person is not affected with the corona, right? That means the accuracy is already going to be 99%, right? 99%. Although the model accuracy is 99%, but even you can say this model is quite crazy enough. It's a poor model, right? Okay, so that means from this example, I just want to teach you, if your data is imbalanced, then the accuracy is not going to be a good enough indicator, right? Data imbalance means 99% of the population of India is not corona affected. 1% of the population is only corona affected. That means in these two classes, the difference is huge. One is 99%, one is 1%. Correct? So in this kind of scenario, the accuracy is not going to work properly. Okay? So in order to resolve the issues associated with this accuracy, we generally use one more indicator of the classification accuracy, which is called as which is generally called as the recall and precision. Okay, recall and precision formula is pretty simple. True positive divided by true positive plus false negative. True positive divided by true positive plus false positive. These are the two different terms, recall and the precision. Generally we use with accuracy, right? If you only give you the results in terms accuracy, people are not going to believe your result. Okay. So let's take an example of COVID-19. Right? In COVID-19, do you think false positive is important or false negative is important? I firmly believe false negative is too important in case of COVID-19 detection. Right? You don't want any person to be negative. Yes, Mr. Bismuth, do you want to include something? Yeah. So, in case of COVID-19, you don't want to declare a person to be negative and false, right? And unfortunately, he is the positive right guy. So you don't want this kind of scenario. So in this scenario, false negative should be as low as possible. False negative should be as low as possible, right? So in my COVID-19 scenario, I will prefer recall over the precision because precision is much more worried about the false positive. False positive means a person is, your model is saying this is a COVID-19 positive, but fortunately he is not affected with the corona. This scenario is still acceptable. We don't mind this scenario, but this false negative is too important here. So for COVID-19 detection, any machine learning or deep learning model, I will prefer recall over the precision. Okay. I hope this makes sense. This makes sense to you people, right? So let's take one more example. Let's take one more example of, let's say, spam detection. Spam detection means these days you must be getting a lot of spam text, right? And there are a few models available in your Google or like Hotmail, any web server you use. They have some machine learning based model which will detect the any email to be spam or not. Okay. So in the case of spam detection, what is more important? In this case, the false positive is more important, right? That means your model is saying this is a spam and which is not, which is incorrect, right? That means false positive. That means your important will go into the your spam, and some people do not check their spam every morning, right? Let's say somebody is joining later or anything, important information went into the spam, right? That means you are losing the too important information. On the other side, if one email which is considered to be spam, because most of us, the academicians, are getting email to submit a paper in some conference paper, journal, garbage somewhere, right? That is a spam, and instead of going into spam, it comes into my inbox. What is going to happen? I'm going to simply delete that email. There is no life threatening situation. In this scenario, precision is much more important. Okay. In the case of spam detection, the precision is going to be important. Okay. So this is all about the confusion matrix, false positive rate, false negative rate, recall, and the precision. But you can see it depends upon the situation where you want to prefer recall or the precision, right? So let's try to find out one more matrix which gives the weightage to both the precision and the recall. Okay, this is called as the F beta. Right, this is called as the beta score. This is a 7 matrix which we are discussing, F beta. So F beta equal to 1 plus beta square multiplied by precision into recall divide by beta square E plus recall. I hope you are able to read this one. So this is the beta which is controlling the weightage of the precision and recall. If you are taking a really huge value of the beta, let's say 20, this means you are going to be more worried about the precision. If you are taking a value of the beta to be really small, let's say 0.001, you are going to be more about the recall than the precision. Okay. So in general, what generally people are doing, they are taking the beta equal to 1. That means if you take beta equal to 1, that means what? 2 P R divided by P plus R. That means what? What is this? This is the simple harmonic mean of the precision and the recall. That's all. Okay. So I just want to say, when you are saying giving the results of your any machine learning and deep learning model for the classification problems, you always need to give results in terms of confusion matrix. You need to give results of accuracy. You need to give results in terms of recall. You need to give results in terms of precision. Okay. So these matrices are really important. Right now in this lecture, I haven't covered how to train your model, but I have told you how to judge the performance of any model. Okay. To the organizer, like how much time I'm left for teaching this?
Sir, till 12:30, sir.
12:30. So there will be some discussion session or no?
Yes, sir. It depends, like how you would like to carry forward. The session is till 12:30. Maybe we can adjourn at 12:15 and invite questions, sir.
Sure. I mean, up to you. I mean, I don't mind both. Thank you. So the next term which I'm going to teach you is the ROC and AUC. AUC means area under curve, right? Generally, what people are doing, they are training their deep learning model or machine learning model. Output is going to be in terms of probability, right? What generally people are doing, if the probability output is less than 0.5, the category is 0. If the output is less than 0.5, the category is 1, right? They are simply taking one curvature. Let's say this is curve, this is 0.5 probability. So this is representing 0, this is representing 1. Simple. And of course, the probability cannot be greater than 1, right? But do you think this is a good enough strategy? I don't think so. The domain expert take the right call, right? My job is to train a deep learning model and everything, but I'm not a medical expert. So I will give my data to the medical expert to find out the threshold. Why should I define my threshold? Right? So now I'm going to teach you in this like next 15-20 minutes how to select the optimal threshold. Okay. So let's say we are going to take some random example. Let's say this was the original label. This is Y and this is Y cap predicted. That means this was the original label and this is the output of your deep learning model or machine learning model in it, right? Let's say 1011001, right? Y predicted, some random values are there, 0.8, 0.96, 0.4, 0.3, 0.2, 0.7, right? These are the Y predicted are the output of your deep learning or let's say machine learning model, right? And I already told you in case of classification, the output is going to be in terms of probability. Okay. So let's say first one, I will choose my threshold to be 0. Let's say threshold to be 0. T is to be threshold to be 0. That means, of course, all the outputs are going to be 1 now. Because all the values are greater than 0. Right? So everything has become 1. Okay. Now I'm going to teach you about two different formulas which are pretty simple to use. One is TPR, true positive rate. That means true positive divided by the true positive plus false negative. Another one is the false positive rate, which is equal to false positive divided by false positive plus true, true negative. Okay, true negative, right? So now let's come for this threshold equal to 0. How many values are true positive? True positive means prediction is positive and originally a positive. So this is a prediction positive and originally it was positive. Prediction is positive, original was positive. Prediction is positive, original is positive. Prediction is positive, original positive, right? So total 4 divided by 4 plus false negative. False negative means prediction is negative and it is false. But here in threshold equal to 0, we don't have any negative prediction, right? There is no 0. So of course it is going to be 0. So in this case TPR is going to be 1. What is going to be the value of the false positive rate? FPR. First we need to find out the false positive. That means the prediction is positive and it's incorrect. So you can see prediction is positive, this is incorrect. Prediction is positive, it's incorrect. Correct? So 2 divided by 2 plus true negative. True negative means prediction is negative and which is correct. But you can see in threshold equal to 0, we don't have in threshold equal to 0, we don't have any prediction to be 0. You can see in this scenario, true positive rate and the false positive rate both are equal to 1. Right? So both are equal to 1. So what we can do is we are going to plot a relationship between them. That means true positive rate, false positive rate. That means for threshold equal to 0, we are getting 1. We are getting 1 everywhere, right? This is for TH equal to 0. Now we will slightly increase the value of this threshold. Okay, let's say I'm going to take my TH equal to 0.2. Let's take some random example again. TH equal to 0.2. In 0.2, what is going to happen? 1, 1, 1, 1. This is 0 now. This is 1. Because only one value is equal to less than 0.2. So it is going to become 0. Otherwise, everything has become 1. Now try to find out the TPR. What is going to be the value of the TPR here? TPR means true positive. 1, 2, 3, 4. So this is 4 divided by 4 plus false negative. In this case, we don't have any false negative. One negative prediction is there, which is correct. So there is nothing called false positive. 4 plus 0. This is 1 again. How about the value for the false positive rate? False positive rate, pretty simple. We need to find out the false positive first. False positive, right? I think this is only, this is correct. This is false positive 1. That's all. We only have one false positive. Okay. 1 divided by 1 plus true negative. Means predicted is negative and originally it is a negative. True negative. So this is the case. True negative 1. So half. Half, right? So let's say FPR is half. This is 1. This is another scenario for threshold. Threshold equal to 0.2. This is representing. So similarly, I will take one more value of the threshold. Let's say threshold equal to 0.4. Doesn't matter. We can take any value. 1, 1, 0, 0, 0, 1. We can similarly calculate the false positive rate and the false negative rate. Okay. So we can create a curvature between them. Let's say some value is coming here, some value is coming here. So let's try to plot this curve. Okay, right? So based upon the relationship of this TPR and FPR, we can find out the optimal threshold. So right, I will give this curve to the, let's say, medical expert. I'm working for the medical expert. I will give this curve to him, and it's his responsibility to find out the optimal threshold, right? Let's say if he says, I want my data to be correctly classified, okay, but I don't want any negative cases. That means I don't want any false positive cases. I'm only worried about the true positive cases. That means this threshold is going to be give you the correct answer, because here the false positive rate is 0. That means there are no negative answers. This is correct. If the doctor says my true positive rate should be as high as possible, and my false positive rate should be as low as possible, okay, then this is the correct answer. Here true positive rate is 1, false positive rate is 0.5, half. Okay, so using this relationship between the true positive rate and the false positive rate, you can identify the correct value of the threshold. Okay, it's not really compulsory to have threshold value to be 0.5. Okay, the threshold value can be anything between 0 to 1, and it is a job of the domain expert to find out the threshold. Okay, make sense, guys? I hope. Right, so right now, up to now, all the time we have discussed about the classification problem, right? Classification problem about the reason, area under curve, confusion matrix, accuracy, recall, precision, everything we have covered about the classification problem. But let's say I have created one model for the regression problem, right? How to judge my regression model is good enough or not? Okay, so generally we have two different uh, methods to do, right? So let's say regression problem. One is the mean square error. Another one is the, let's call it E. MAE. MSE means mean square error. MAE means mean absolute error. Right? You remember in previous example, the prediction value was there, Y and Y predicted, right? So MSE is pretty simple. This is the formula, pretty simple formula for the mean square error, right? What is N here? N is the total number of samples available for training. Okay. What is this Yi? Yi is the original actual value of the data. Y cap is the, Y hat is the predicted value of the data using your model, right? Then we take a square and take the mean of them. This is mean square error. Another one is the mean absolute error. Pretty simple again. 1 by n, I equal to 1 to n, absolute yi minus yi predicted. This is mean absolute error. Okay. But now, guys, I hope you are able to understand about this mean square error and mean absolute error. But one thing we don't know right now, which one to prefer? We should use mean square error or the mean absolute error, right? Mean square error problem is we have one square term here, right? Let's say one x in my training data, one value was behaving like the outlier. That means I was trying to predict the price of a house, okay, and the value was in outlier format 1,000 million, for example, right? one value was 1000 million, right? Because of that, in outlier, the error will be really high, and now we are taking the square of them. That means because of one particular value, your mean square error is going to be really huge, correct? Because we are taking the square of the error. So this is the problem. Why? Right? One outlier can like spoil the complete your machine learning model. Correct? So this problem can be solved using the mean absolute error. Mean absolute error means you are not taking any kind of square. We are simply subtracting both the data and make it as a positive value. In this case, error is not going to be amplified. Okay? So mean absolute error is going to work nicely in the case of outlier. But mean square error, if some outliers are available in your data, it is going to perform so poorly. Okay? But some catch is still there. Maybe the speaker who are going to teach in the later part of this course, they will teach you that you always need to differentiate this mean square error in order to find out the like optimal weight. So differentiating square is pretty simple, right? Because this will give you some closed form solution. But if you want to differentiate the absolute value, it is a really difficult to do. It is not really easy to differentiate the absolute term. Okay, so now I hope there is a trade-off. Outlier, don't use mean square error. Outliers are there, use mean absolute error, but it is going to take a lot of time to converge, right, and find out the optimal solution. So mean absolute error is quite complex in nature. Okay, right? But mean square error is quite like fast in nature. But outlier, don't touch mean square error. Okay. So guys, I'm done with my presentation. If you have any question and answer, please feel free to ask.
Participants, you may now please use the chat box to type your questions.
Sir, good afternoon.
Hello. Good afternoon. Yes, please.
Sir, I'm from Alakrishna from Chennai.
Hello, sir.
So, what algorithms and library files using for the computer vision, sir, in AI model?
Oh, computer vision. Yeah. Why not? Why not? Why not?
Hello.
Yeah. I'm doing it. Are you able to see my screen? I'm going to write it down here.
Yes, sir. Yes, sir.
Right? Even in both Python and C.
Yes, sir. So, what are the frameworks they are using, sir? Is there any particular framework
Yes.
using for the AI development module, sir?
Mr. Bala, I'm going to answer your question. Give me a second, please. Right?
Yes, sir. Yes, sir.
So in Python and C, something called Opencv. Opencv is like a kind of library where all the functions has been predefined. Okay, so the answer for your question is Opencv. And believe me or not, Opencv is quite rich in nature. A lot of algorithms, a lot of machine learning algorithms has been already defined there. Right? Reading an image, writing an image, whatever problem you can think of, the solutions are available in Opencv. Okay. Dr. Bala, any other question do you have?
Yes, sir. Sir, is there any special library file for testing the computer vision, sir?
No. See, for computer vision problem, whenever you are playing with the images, this, I mean, for testing the model for images is not a really difficult task. What general people are doing is
Yes, sir.
peak signal to noise ratio. Maybe you heard about PSNR.
Yes, sir. Yes, sir.
PSNR. PSNR, let me write down the formula 10 log to the power 255 square divided by the mean square error. High PSNR, good model. Poor PSNR, poor model. Okay, so you can use PSNR, or the formula is so simple, so you can implement it by yourself. And I think in OpenCV it has been already defined, so no worries. Right. Another one you can use is SSIM. Right. SSIM is the similarity index, structure similarity index. Okay, SSIM. SSIM you can use to find out if your model is performing well or not. Okay. Dr. Bala, any other question do you have?
Yes, sir. Thank you very much, sir.
The other participants, if you have anything to clarify or add on, you may please do that. You can kindly use the chat box to type your queries.
Guys, please feel free to ask questions if you have any. Please feel free.
Sir, you have mentioned that the deep learning is used for identifying the variable before going for the prediction. That is, am I right, sir?
Okay.
Deep learning, you have mentioned that what are the variable or parameter that normally be used, that for identifying that, the deep learning is used. Am I right?
Yes, exactly. Yes.
So apart from that, what are the other uses of this deep learning, sir?
Dr. Muthu, sorry, my pronunciation might be wrong. So whole idea is, in this world, most of the problems are prediction problems, right?
Yes, sir.
You have seen some kind of data experiences before. Based upon those experiences, you want to predict in future. That is the job of the prediction, right?
Yes, sir.
But this prediction is useful in millions of different problems, right? And in these millions of problems, you need to identify how many layers you want, how many parameters you want, right? How you want to initialize them, right? Your amount of data. If the amount of data is available, that means overfitting is happening. How to handle this kind of situation? The deep learning model is going to do everything. What generally deep learning model is doing for all the unknown parameters? They are going to start with a really small value. Let's say 10 to the power minus 3. All the parameters. Okay. Now your deep learning model is going to train in several steps to these parameters to be as accurate as possible. Okay.
Nice, sir. Nice, sir. Sir, one more. You have mentioned about this 4-week courses in the Coursera. That can you able to highlight the details again, sir? You mentioned about a free course available regarding ML in the Coursera.
I can show you the link.
Please.
Are you able to see my screen? No, not yet.
Okay, but it is loading. It is loading. Not yet.
Yeah, I'm doing it now. Right?
No, still loading, sir.
Visible, sir. Still loading.
I will copy paste the link actually. No worries.
No problem. No. Okay. You put it in the chat box. We'll look into that.
Yeah, that's what I'm doing.
Thank you.
I'm still learning this.
So some people have asked for some reference texts. If you can suggest that also.
So I'm just typing the link of the course. One course, 5 different modules are there, and believe me, they are really, really good enough. Okay. And some people are asking, is this video will be available later? Can we have access for all the videos? For all
that we need to take the consent of the resource person. Later, we will intimate to the participants, sir.
Guys, any other question? Oh, a lot of
Sir,
questions.
not a question. I want to give a small suggestions. So, if you would have used that presentation by explaining all these concepts, that would be better, sir. But while using a small use cases, you can use this interactive board. It is my own suggestion. So, if you most of the time, and you are writing the variables, some of the variables and all, some of the things and all not visible, And that's why simply I'm suggesting if you would have used that PPT or some other presentation, and at the time of using the use case and the problems, you can use this interactive note, this one note. That would be better, sir. This is my humble suggestion for
Okay.
you.
Okay. Guys, any other question do you have?
Dr. Vinit, would you like to suggest some further reading material? Some people have asked for it.
Sure, sure, sure. See, the in India, the most famous person who is working in this artificial intelligence is the Professor Deepak Khemani from IIT Chennai, actually. Right? So there is a book by Professor Deepak Khemani on this area. That book is really, really beautiful. So if you have much more interest, please read that book. Okay? Professor Deepak Khemani from IIT Madras. Okay?
Sir, there are some comments on the chat box. You can just have a view.
Yeah, sure, sure. How we remove those FP and FN? I think Kajol Gupta asked this question. How we remove those false positive and false negative? The answer is you need to train your model with more amount of data. Your model is not really good enough right now. That's why we are getting the false result. Okay, so you need to either retrain your data with more data or with a better organization of different kind of layers. That is the only solution. Okay. Okay. Mr. Ravi Raj asked me one question about explaining this confusion matrix one more time. So let me do it. Okay, so let's try to understand one confusion matrix one more time. Let's say this is actual level of the data. This is predicted. So your model is predicting, and this is the predicted data. Okay. This is true, false, true, false. So of course, this is going to be true positive. This is going to be true negative. This is going to be false positive. This is going to be false negative. Right? This is a confusion matrix. Okay. So this FP represents means what? This first digit P. P means what is the predicted. In this case, predicted is true. That's why this is P. F means whatever it has been predicted is correct. That means the true predicted is in this case is true, but in reality this is a false. That's why false positive. Predicted is false positive, but it's incorrect. Okay, that's how we create this confusion matrix. True negative means what? Predicted is negative, and in reality it is a negative. That's fine. True negative. I hope Mr. Ravi, I answered your question. When to use the confusion matrix? All the time you need to use confusion matrix because confusion matrix gives the bigger picture. Confusion matrix gives the bigger picture that how many times you are classifying correct data into correct, how many times you are classifying positive data into negative category and negative data into positive category. Okay, so if you are creating any classification algorithm, you always need to give results in terms of confusion matrix. Okay. Okay, this is a nice question by Mr. Raghavendra. Is confusion matrix used only for the binary variables? No. The example which I have given you here is for the binary classification, but you can extend this matrix for the multi-class classification easily. Okay. Uh, can you suggest book which refer for machine learning and deep learning? I already told you that a book by Professor Deepak Khemani from IIT Madras. Pretty nice book. what is the difference between classification and regression? Classification means class. One data is there. This data is going to belong going to belong to either class 1 or 2 or 3 or 4. Regression means continuous output. Right? Data is coming. Based upon the data, you will predict like 0.1, 0.2, 0.3 continuous. Right? That is the difference between the classification and the regression. I hope I have answered all the questions. Any other questions, guys? Please feel free if you are.
What?
Sorry, Rohan, you're not able to move.
No, it's not audible. Can you please type it in the chat box?
Meanwhile, we can take another question.
Yes.
Meanwhile, Rohan is typing, we can.
So you told that in Coursera the courses are available, right? Which is free of cost, neural networks and deep learning. But the problem is when I try to enroll this course, it is suggesting 7 days trial only.
Raghavendra, actually, there are two things. If you want to enroll with the certificate, you need to pay money.
Yeah.
Want to enroll without certificate for your own knowledge, it's free. Other solution for this problem is you can apply for the fee waiver.
Okay.
And fee waiver will reply you within, I think, 3-4 days. And most of my students which I have seen at IIT Jammu, they are applying, and by seeing the we are coming from the developing country, generally they make it free. Okay.
Thank you.
Write down a really proper email suggesting that we are poor, all of us are poor. They will waive it off. Okay. Any other questions, guys?
So somebody has asked, Mr. Raviraj has asked, how can we use ML and AI in defense sector?
Defense sector, too useful actually, frankly, in defense sector. Defense sector, I can give you one example. You in defense sector, what is going to happen? You because in night time the visibility. I'm trying to give you one example only, but millions are there. Right? Night time visibility is too poor. So what the defense people are doing? They are kept putting two different cameras. One is the night vision camera, infrared camera. Another one is the normal camera. Okay, two cameras images are available. Right? In night vision cameras, I mean infrared cameras, only the structures are available. Right? They will show my face, but no structure on my face is going to show. Correct? Some structure will be there, but you can't identify this is a tiger is there or some terrorist is there. No. So what generally people are doing? They will take two images using the deep learning. They will choose one more another fused algorithm where how they are going to fuse using the deep learning model. Okay. In this fused algorithm is able to see different objects and the different kind of structure. Okay. This was one of the examples. Another example, a pretty nice example I can give you. You must be familiar with LOROS, right? LOROS, right? Because as you are from defense sector, you must be familiar with LOROS, right? Okay. So in LOROS, what is going to happen? They are capturing one information from too far, right? With really nice cameras. They are going to identify the person. How they are going to identify the person? Once you get the video stream, apply the object detection algorithm, right? So in LOROS, deep learning is there. I mean, I don't want to say in LOROS it is there, but the application in which the LOROS is working, we can apply using deep learning. Okay. I think how we use ML in applications like voice translation? Mr. Bismuth is asking. See, not machine learning directly, but a lot of people are using recurrent neural network or LSTM for the voice translation. They are doing a lot. Okay, LSTM or RNN you can use it. Mr. Shrish has asked one question. Should I use actual predicted? See, he has asked in this confusion metric, these actual values are already fixed. We cannot modify it. These predicted values are going to be based upon the prediction model you are using, which deep learning model you are using. Based upon this, we can find out. Okay, so these predicted values are going to change all the time, but this actual has been fixed. Okay, guys, any other question? Any other question? Organizer, we can wind up this session if there are.
In case if there are no more questions, I think there's one more question. How effective is ML and AI in the field of biotechnology at present?
Frankly, I mean, I'm not a right person. I'm sorry, Saranya. I'm really sorry, but I'm not an expert in this biotechnology, and frankly, I never read any papers related to biotechnology. So I'm sorry, I don't have the answer for this problem.
Maybe there are further sessions which will provide you more clarity on this, maybe. Yeah. So I think now we'll call this session. We will now adjourn for lunch.
Okay.
Before we adjourn for lunch, there are a few. Yes.
I'm sorry, I just want to answer one more question from Kajol Gupta.
Sure, sir.
Sorry for interrupting. Yeah. So she asked earlier. I told you that this X-ray was not good enough for COVID-19 detection. The reason was they were confused a lot between the tuberculosis and the COVID-19. Right? They are giving the same kind of pink patches in our chest X-ray images. That was the reason. And another one, they were giving a lot of false negatives. Model accuracy was good enough, 96-97%, let's say, but they were giving a lot of false positive. I mean false negative. That means person was not affected. No, false negative means person was affected, but the model was saying it is not affected. This because of the false negative, the models were not really good enough. Okay, thank you.